Okay, we are in the home stretch here, the last talk of the symposium. So I know everyone's looking forward to getting out of here and hanging out in freeway traffic afterwards. I'll try and not take too long to keep everyone from their Friday evening. All right, so my name is Chris Banks, and I'm a toxicologist at the Office of Environmental Health Hazard Assessment. I'm also the chief of the water toxicology section. And today I'm going to talk a little bit about PFAS regulation in California. So as we've seen, PFAS is a worldwide issue. It's not restricted to any particular geographic location. And California, like everyone else in the world, we are very interested in dealing with PFAS, learning how PFAS impacts populations, learning about the health effects of PFAS, and learning what we can do about this situation. And so the California Environmental Protection Agency, which is made up of a bunch of different organizations, and some additional sister organizations like the California Department of Public Health and Department of Food and Agriculture, we are all working on dealing with PFAS issues, including how to identify and control PFAS sources, how to assess human health and conduct ecological risk assessments and look at ecological impacts as well. We're also looking at cleanup and promoting safer alternatives and also biomonitoring. So there are lots of different activities that California is doing to deal with PFAS. And so I don't want to spend too much time on this slide. I just wanted to emphasize that all of these different organizations within the California EPA and sister organizations are really tackling PFAS according to their own areas of expertise. Like for example, earlier today we heard from Wendy about the great work that the Water Board is doing in terms of sampling PFAS across the state and trying to develop new methods and new approaches to deal with these huge unknown amounts of PFAS that we have to deal with in water. So I think that's fantastic. For the sake of this talk today, I'm really going to focus on what my organization does, OEHA, in terms of determining health advisories for drinking water. That will be predominantly the focus of this talk. So I also wanted to give a quick nod to the Biomonitoring California folks that OEHA does partner with. And they're doing some great work by looking at various populations within California and monitoring PFAS levels in these diverse populations. And what we are finding is that greater than 95% of participants, we are finding PFAS, which tells us that this is a real problem for pretty much all Californians. We're all being exposed. We are all having to deal with this together. So this is something that affects all of us, and it's important for California to step in and try to mitigate these types of exposures and deal with any sort of health issues that may come our way. So a little bit about drinking water health advisory. So my section, the water toxicology section, we are involved in developing public health goals and notification level recommendations. So a public health goal is the level of a chemical contaminant in drinking water that does not pose a significant risk to health over a lifetime. Now, public health goals are non-regulatory, and they're based solely on health considerations. And when we develop these, the Water Board, or State Water Board, will use the public health goals as sort of the scientific basis when developing maximum contaminant levels. In fact, they are compelled by state law to set maximum contaminant levels at levels as close to the PHG as possible while considering economic and technological feasibility. So for public health goals, we do develop health protective concentrations both for carcinogens and non-carcinogens. And the lower value of the two is designated as public health. And so when we do look at carcinogens, we do set an acceptable risk of 1 in 1 million extra cases over a lifetime of exposure. And public health goals are rigorously developed. They do undergo external scientific peer review, and they do also undergo multiple periods of public engagement. So we have multiple public comment periods. We hold a public workshop where we can get feedback from interested stakeholders. So this is a very public process, what we do. We also develop notification level recommendations. And so notification levels are health-based advisories that are set by the Water Board for chemicals that do not have maximum contaminant level. The idea being that if a water system detects a particular chemical with notification level that is in excess of whatever that notification level is, that water system should notify the consumers that there has been an exceedance of this particular chemical and potential health effects associated with that exposure. The Water Board also sets response levels, which are typically 10 for non-carcinogens, 10 times over the notification level carcinogens, that are 100 times over the notification level, where if those levels are exceeded, if you reach the response level, then the water board recommends that that water system be taken offline. All right, so in California, we do have public health goals for PFOA and PFOS. Not surprisingly, since these are the best studied of PFAS. And I just want to echo what Matt had said earlier, although this is, kind of a drop in the bucket, it is a step in the right direction. And we are working towards, it is a good step for us for California to adopt. And these were just finalized a few months ago in April of 2024. I do want to point out that, I'm going to talk about PFOA first. We determined a PHG of 0.007 parts per trillion based on kidney cancer in humans, and a health protective concentration of 3 parts per trillion based on increased risk of liver damage in humans. So in this talk, I didn't really want to throw a bunch of numbers, formula at people. I really wanted to take a more qualitative approach and a qualitative look at the data that we analyzed when deriving these types of numbers. So, of course, I am happy to answer any questions that anyone may have about how we go from point A to point B, or how we go from a point of departure to what the actual final PHG value is. But I don't really spend a lot of time going through the mathematics in this talk. Okay, so starting off with PFOA, we wanted to, when we initially started, and given these PHGs have been in progress for many, many years. We've started looking at PFOA and PFOS back in 2017 or 2018. And since these are very well-studied chemicals, there is a lot of toxicity data associated with these chemicals. So for PFOA, when we looked at the toxicity in animals, we found lots of various hazards associated with PFOA exposure, including cancer, immunotoxicity, liver toxicity, perturbation of lipid homeostasis, thyroid toxicity, developmental and reproductive toxicity, and other additional toxicities that one might not necessarily have predicted, like effects on adipose tissue, effects on bone. I thought we saw some really nice talks earlier, kind of going over some of these particular types of toxicities in relation to exposure to PFOA and PFOS. And so when I look at this, I see, okay, well, PFOA is really affecting lots of different physiological systems. It's not really a targeted attack. It's really affecting multiple aspects of human health. And so since we are doing human health risk assessments, if human data do exist to help inform our risk assessment, that is going to be preferable over the animal data, simply because we don't have to worry about doing these interspecies extrapolations between rodents and humans. Since if we have data in humans, let's go ahead and use that. And so when we were doing our cancer analysis for PFOA, we did identify a number of really good studies that found positive association between PFOA exposure and kidney cancer. So these 4 studies here, the Shearer study, Vieira, Berry, and Steenland and Waske, all found a positive association with kidney cancer and PFOA exposure. And looking at the top 2 studies, Shearer and Vieira, when we actually look at the serum PFOA levels, we actually found really good dose-response data when looking at the odds ratios for development of kidney cancer. As you can see here from these plots, we are seeing a really nice dose-response relationship. And we use this as the foundation for setting our public health goals for PFOA. We were able to take these slopes here, and using the background level of risk of cancer in the United States and clearance data, we were able to actually calculate a risk per unit dose, which we then were able to extrapolate out to a 1 in a 1 million risk for people in California to determine what the public health goal actually is. And in looking at the non-cancer health protective concentration for PFOA, we went back to the human data. And as we saw today, there are lots of different endpoints to choose from. One of the endpoints that we did consider was the immunosuppression that we see from those studies from the Faroe Islands as well. Those were good studies, but we also looked at other endpoints, including reductions in birth weight. We looked at changes in ALT, and when looking at everything, we ended up going with the increased levels of serum ALT. And as Dr. Chatsi mentioned earlier, ALT is indicative of liver toxicity as well. And we really liked this study because there were lots of good things about it. It had a very high sample size. We had an N of over 46,000 people. And importantly, there's a lot of support for this particular endpoint in associations with PFOA and increased ALT in the literature. Lots of studies to support, so we see lots of consistency across the literature. And from this dose response data here, we identified no observed adverse effect concentration, which we were able to use as a point of departure. We could apply certain factors, clearance data, to determine acceptable daily doses and then extrapolate that out with exposure data to a public health goal, a non-cancer health protective concentration of 3 parts per trillion. Okay, so moving on to PFOS. So similar to PFOA, we looked at the toxicity in animals, and once again, we see this wide range of toxicity across multiple physiological systems. Cancer, immunotoxicity, liver toxicity, very similar to what we see with PFOA. One difference, however, was that with the PFOS data, we were able to identify multiple neurotoxicity studies, which was something that we didn't really see in the PFOA literature. So even though there are a lot of similarities between PFOA and PFOS, they're not exactly the same in every way. And one other major difference that we did find when looking at the cancer data in humans is that we were not able to really identify a good PFOS human study, or at least with data that we could use to drive our PHG. So when we did do our cancer analysis, we were forced to use the animal data. So in this case, we were looking at the study done by Butenhoff et al. Using data from Pomford 2002. So this is a 2-year dietary study where rats, male and female rats, were given PFOS in their diet for 2 years, and cancer was checked afterwards. So basically what we see is that after the 2-year period, we do see significant increases and a positive trend in hepatocellular adenomas. So we are seeing increased liver tumors in these animals. We are also seeing a positive trend in the pancreatic islet cell and adenomas as well. I'm sorry, in the carcinomas. And so we are seeing pancreatic effects from PFOS exposure. And using these data, we were able to calculate cancer slope factors, which we were then able to extrapolate to a 1 in 1 million risk to get our final PHG value of 1 part per trillion. So looking at the non-cancer health protective concentration, we did go back to the human data. And as Andres talked about earlier, there is a lot of data regarding PFOS and increases in total cholesterol. And we found that this study from Steenland 2009 was the best study for us to use in determining our health protective concentration. This was a really good study. There was a very high sample size. Confounders were adjusted for, and importantly, when you adjusted our analysis to account for other PFAS like PFOA, this relationship remained. And so we were able to, from this study, we were able to identify a lowest observed adverse effect concentration here, and then use that as our point of departure in order to get to our final PHG value of, health protective concentration value of 2 parts per trillion. So once again, we did look at all the different types of endpoints that were out there for humans, and we found that that the total cholesterol was the most sensitive. And that this is an important endpoint in general because cardiovascular disease is an important consideration, and it is a big health effect that the population deals with. So as this being a major risk factor for that, it is something that we felt that was very important to consider. Just want to add a little bit about notification levels that we've done as well. So we have done notification levels for 2 additional PFAS, for PFBS and PFHXS. Interestingly, we used animal studies as the basis for these notification levels. And we did find that thyroid toxicity was the most sensitive for both of these chemicals. Now, these chemicals are similar in structure. It's the C4 and the C6 sulfonic acids, respectively. But as you can see, the actual notification level recommendations are quite different. 500 parts per trillion for PFBS and 2 parts per trillion for PFHXS. And that might be related, it's most likely related to the differences in half-life between them and different pharmacokinetics, as the half-life for PFBS in humans is about a month, whereas for PFHXS it's about 5 years or so. So even though they're structurally similar, there are still major differences between them. And when we look at the additional health effects, we see the similar usual suspects that we've seen with PFOA and PFOS, with immune system, liver, kidney, reproductive and developmental toxicity, and so forth. I will point out that as far as I am aware, there are not any cancer bioassays for these chemicals, so the carcinogenic hazard is unknown for these chemicals at this point in time. Okay, and one last thing that I do want to talk about is that at OEHA, it has been mentioned previously that it's impossible to do a one-by-one chemical, one assessment per chemical. It's just never going to happen. Considering that there are, what, 12,000 plus PFAS out there, it's just not going to happen. So we need to come up with additional ways to do things in a more high throughput manner. And the truth be told, the vast majority of PFAS have no toxicity data. We don't know anything about them, really. And so at OEHA, we developed a new section, which is called the New Toxicological Evaluation section, that's really looking at new methods to really get at these types of problems. So this includes using computational modeling and read-across approaches to try to derive, regulatory values for data-poor chemicals or for chemicals that we don't have any data, using alternative methods, whether they be QSAR relationships or quantitative structure-activity relationships, PBPK modeling to kind of track different kinetic processes of these chemicals, other read-across learnings, including machine learning and so forth, looking at high-throughput screening and imaging techniques to try to generate data at a quick scale that we can use to then read across to other chemicals. Advanced imaging techniques, looking at different omics applications to try to generate more data, looking at cell cultures, both 2D and 3D cell cultures, looking at organoids, spheroids, organ on a chips, any other types of data that we can incorporate into our assessments. Because the truth is, we are no longer going to solely be able to rely on animal data. It's just not going to exist for the vast majority of compounds. And as we are learning about more of these compounds, and we've heard, it's very difficult to detect these compounds. We don't know a lot of what they are. And so moving forward, we are really kind of thinking in new ways of how we can do these types of assessments and how we can advance the science of risk assessment. So to summarize, I just want to reiterate that California is very active in its dealings with PFAS. And we are looking into doing regulations and doing actions to minimize the impact that PFAS has on our society. And so PFAS is associated with numerous adverse effects across multiple physiological systems, from cancer to reproductive effects, liver toxicity, you name it, we see it with PFAS. And at OEHA, we have completed several PFAS assessments using both human and animal toxicity data. We've got PFOA and PFOS done for the public health goals, PFBS and PFHX, that's for notification levels, and we have additional notification levels in progress that we are currently working on. So there will be more to come in the very near future. And with that, I will be happy to answer any questions with the rest of the panel.